Hey everybody, this is Mr. Storm. I'm not going to turn on the camera for this video because you don't really need to see my face for this. What you really need to see is the code. This video is going to be a complete walkthrough of everything I did to build this game, to build this project from start to finish. I'm going to go over every script that I wrote. We'll talk about all the systems and how they work together. This is going to be kind of a long video, but this is for those of you who are curious as to like how a game gets put together, how a game gets completely built. This is not going to be a full tutorial on how to build this. This is just going to be kind of a code review, essentially. Okay. So I guess let's start with the beginning. Let's start with the main menu. So the main menu scene is literally just a canvas with a bunch of different panels that I can turn on and off. We have the main panel as the background. We have our text, which I had as two separate text objects so I can rotate them and size them differently. Just make it look more interesting. I have my marble image and my end goal image. Both of them have, if we look, I have a smooth rotator script with a rotation speed. Let's take a look at that script real quick so you can see what that looks like. It's opening on my other screen. Let me drag it over here. Oh, that's OBS. You don't want that. You want this. There we go. Okay. So let's zoom in a little bit. Can I not control? There we go. So this script is the most complicated thing in the world. Just kidding. It's very, very easy. We just have a public float variable rotation speed, which is going to set how quickly we rotate. And all we're doing is we're setting the rotate property of the transform, or we're setting the rotate value of the transform property to rotate on the z-axis, our rotation speed times time dot delta time. It's that simple. It's a very, very simple script to write. Very simple script. So that's just making these rotate. And one of them I have going in clockwise. The other one I have going in counterclockwise. And that's just done by setting a negative rotation speed if I want it to go the other direction. Why is it taking so long to build? I think it's because the first time I've used it today. That's probably why. There we go. Now we're getting there. Woof, that's very loud. But anyway, let me turn the music and sound effects off for today. So you can see I have one going counterclockwise and one going clockwise. It's just, that's what the rotation script is doing. Perfect. Then I have, inside my menu panel, I have a vertical layout group, which is going to lay out these buttons in a vertical form. And I can change the spacing here to whatever I want. I think it was at 25. And the alignment and all that stuff. That way they look consistent. Let's see, I have a play button here, which its on-click method is tied to main menu UI scripts. Let's take a look at that, because that's going to handle everything. Where is it? Main menu UI. There we go. So this is going to handle everything on my main menu. So we have some public references to game objects, basically all the panels in my game. The idea of the script is basically I'm just going to activate panels whenever I need them and deactivate them when I don't. So I have my main menu panel, options panel, reset confirmation panel, and my credits panel. So I'm basically going to activate or deactivate these as we go. I also have my sliders for the volume. And I'm importing my audio manager script into here so we can change the volume in our audio manager. I'm going to talk about the audio manager when we get there, but hooey. All right. So when the script starts, we are finding an object of audio manager. Now this little error, this is a new thing. Apparently find object of type is deprecated in this version of Unity, but it doesn't actually break the game. It just gives me some warnings whenever I run the game, but everything's perfectly fine. So I was like, I'm just going to keep it. It actually works the same way. Just Unity is picky about deprecated stuff, but it actually still works. So just ignore that. So we're finding the audio manager. I could have made a public reference to the audio manager and just made this public and then dropped in the audio manager instead of doing this, but whatever. By the way, before we get too deep into this, just know that I completely understand that this code is going to be, there are going to be some things that I do inconsistently. You're probably going to think like, why did he make a public reference for that thing? But then he looked for it in the code, in the other script, and you know, why are these, here's a method that he's not even using anymore, here's, you know, references that don't go anywhere, whatever. This is spaghetti code. I wrote it in a week. All right. So we're going to play music right away. We're going to get the value of the music slider. So basically we're setting the slider value to whatever our saved music volume is in the audio manager. So it's going to go out to the player preferences. And it's going to say, okay, what was the last time, or what was the last value that they set the music slider to and the sound effect slider to? And then we're going to put it back to that. So that way, whenever you play the game, the sliders are in the same spot, and it represents the correct volume that's actually playing. Then we have a play game function that basically just pulls up the level select screen. That's easy. And then we have all these other functions: open options, close options, confirm panel progress, cancel reset, reset progress, open credits. All of these panels are basically just changing the active value for all these panels, like turning it on, turning it off, so that we can pull up a new panel whenever we get there. Set music volume and set sound effect volume. These are literally just calling another function by the same name in the audio manager. I could have just referenced that function, but I forgot that I wrote it until I got to this point, and then I was like, well, whatever. So it's whatever. That's another thing. Obviously, that's not the cleanest way to do things. I probably should have, and actually has 0 references to that. Oh no, I'm tying to, yeah, never mind. I'm tying it to the thing. I could have just assigned the audio manager and just did that. Anyway, whatever. You get it. Yeah, so that's the main menu. It's a main menu in Unity. It's very easy. The audio manager stuff is a little bit wonky, but whatever. We can get to that when we get there. The audio manager script, I'm actually kind of proud of it at this point, just because I worked on it for so long, but let's get into it. Why not? So let's talk about the audio manager script. The audio manager is in every single scene. Notice that I have a bunch of public references here, just so I can drop in whatever sound effects I want. And I have a public volume setting, so I can play around with that and debug it. Let's take a look at the audio manager script. Okay, so here's all of our public references. Oh, down here. These are all the public references that we have in Unity, just so I can modify which sound effects I'm playing or the music for each level very quickly. We also have a constant string key, a music volume key, and a sound effect volume key. This is, you'll see how we're using this later. Alrighty, so at the very beginning, we're applying saved volume. This function, where is it? There we go. Apply saved volume. This is the last function I wrote for the script, because this is the one that was actually helping me to fix all the problems I had with it. Basically, what this is going to do is, before anything else happens, we're going to get the volume from the player preferences. So basically, the last time they set the volume, we're going to get it from player preferences, and then we are going to apply it to the music source and the sound effect source. We're basically setting the volume before anything starts. I was having a lot of problems with things loading at the same exact time, and some things would happen before other things, and it was just not working properly. So I had to kind of break it out like this to make it a little bit better, a little bit easier. I could have done that on Awake as well, but it's fine, whatever. So we're setting or applying the volume before we start playing music. I'm also checking to make sure the music source is playing, or music source isn't playing, and making sure that I actually have background music assigned in the inspector. That's just a safety thing. So that way, it if it doesn't have both of those things, then it just wouldn't play music instead of giving me a reference error. Then we have play music. Play music's pretty simple. Basically, if again, we're checking again if music source equals null or clip equals null. So if I don't have a music source referenced, or I don't have a sound effect or a music clip reference, then we're just going to return. We're not going to run this function at all. If we do have a clip, and our music is playing, then I just wanted to throw a debug statement saying the music's already playing, and then we return. So that way, if it tries to play the song again, then it won't. Perfect. Alrighty, and then we have music source stop. I want to stop the music before I start playing the next thing. We're going to set the clip to equal clip, set loop to equal true because it's background music, and then we play the background music. And I also have another debug log sending music out there, or telling me what song is playing. I can actually get rid of that because I don't need it anymore. That was just, I was trying to troubleshoot something. We have our stop music function, which honestly, I don't need. Okay. If that is, I am referencing it later on. So, okay. That's weird that I wrote that function actually, because I could have just played music. I could have just, all right, whatever. I don't know why. Again, this was very late at night when I wrote this thing, and I'm not going to get rid of it because I don't want to break anything at this point, but it doesn't make sense to write this function when we already have stop, which exists. And the only thing this function is doing is checking to see if the music source is not null and the music is playing. So it's only stopping it if the music is playing, but there's no error if we just call stop anyway, whatever. I have fade out music, which I can use if I wanted to fade out the music, but I'm not using it. You can see there's no references to it. It was just something I wrote just kind of as a gee whiz thing, but I tested it and it didn't really make sense. It was fine, whatever. So I just never used it. So again, I can get rid of these two functions probably, if I really wanted to, but I'm not gonna risk it. I'm gonna leave it alone. All right. Then we have coroutines. So coroutines are something that you really, really, really want to get good at if you're going to do any kind of game development, especially something that has complicated script behaviors. So like I have a ton of scripts written for this one very simple game, and they're all integrated with each other. For example, the audio manager and the game manager are very inextricably linked, but they're being called at the same time. So when the audio manager loads and the game manager loads, they're both doing what's in their start function at the very beginning, or awake if we have an awake function. Then it's doing what's in the awake, then the start, then it's going to start running the update function, right? If your scripts are running at the same time and things are supposed to happen in a specific sequence, your functions will run, but nothing else will run in that script until that function is done, right? So coroutines allow you to play a function at the same time as another function is playing, so that things can happen concurrently. And so that's why we use coroutines. Coroutines are incredible. So this fade out coroutine, which I actually don't need because I'm not using fade outs. What this will do is it'll allow me to actually do all this while other things are happening in the background. So it'll just fade out the music. Okay. But coroutines, you're going to see a lot of coroutines in this script or in these scripts, because they're kind of necessary. They're necessary. Things have to happen at the same time sometimes, and you can't just make everything wait for something else to happen. Sometimes you can, sometimes you want that. But for this, for a lot of the interactions in this project, you're going to see coroutines for those. Okay, play sound effect. This is very easy. Just plays a sound effect. Here's an overloaded method. So notice that they have the same name, play sound effect, but this function takes in one argument, and this function takes in two arguments. I did this because the bounce sound effect, when the marble hits the edge of the level, was very loud. And I noticed that when I wrote the play sound effect, I didn't have there was no way for me to modify the volume, but I didn't want to have to go back everywhere else I was calling this function and add a volume argument to every function, because I'm calling it all over the place. So I was like, let me just write an overloaded function for this, and then I can only use it whenever I need to actually adjust the volume. So that's what I did. It's just it's just a programming trick. You don't have to, you can write functions of the same name, just with different argument sets. So, set music volume. This was, I guess I did have a set sound effect volume, didn't I? I could have just called this fun. See, this is what I'm talking about. This was very late at night. I did not review any of my code, and I just kind of wrote what I thought I needed in the moment. I do. Oh, no. I know what this is. This is not set sound effect volume. This is setting the overall volume for all of my sound effects in my player preferences. That's what this is. So I did need that because I only wanted to change the volume of one specific sound effect. There we go. Okay, so I'm not crazy. This actually is what we want. So set music volume, set sound effect volume. These will take the value of the sliders, essentially. Well, these are being called whenever I move the slider, and it's going to set that volume that we set the slider to. It's going to take that float value, and it's going to apply it to player prefs or player preferences. It's a very easy way to save progress in Unity. It creates a kind of like a save file for the player on that machine. So if you're playing it on your phone, you have a different player preferences settings than if you're playing it on PC, right? I have a button in the main menu options that allows you to reset your preferences, or basically reset your progress, because player preferences stores not only the volume for the audio manager, but it also stores your progress on each level. So how many stars you earned on each level. So you can reset your progress if you want to start over from the beginning. So that's what these functions are doing. They're basically just setting the volume they're taking the value of the slider and applying that to the volume, and they're saving it to your player preferences. So you don't have to reset the volume every time you open the game. And then here's that apply saved volume function that I talked about. All right, so that's the audio manager script. Not as bad as I thought it was going to be honest with you. Sorry. Okay, let's go to the level select screen real quick. Let me go to my scenes, and we'll open up the level select. Sure, I'll save a change. Did I make a change? Uh-oh. Okay, so the level select screen is blank in the Unity editor. That's because I have a script that dynamically creates the amount of level buttons that I need. Let me show you what that script looks like. Here's my level select UI script. We'll talk about that in a second. We have a scroll view here, just in case the amount of levels that I have gets to be bigger than the container that I'm putting it in. I put it into basically a scrolling viewport. And I have a level grid. So this level grid has a level select manager script attached to it, which allows me to put in a prefab of the level button. Let me show you what that prefab looks like. Level button. This is the prefab. So it's just a button with a number on it and 3 stars. So we have star 1, 2, and 3. So I'm loading that prefab in, and I'm setting how many levels are here. So I can change it to 15, 20, whatever. I can set it to say 20, run the script, and now I'll have 20 levels instead of 12, although anything after level 12 is not going to be, we're not going to be able to do anything because it's not tied to anything. But you can see we have 20 buttons now, right? So anyway, cool. So let me go back and change that to 12. Perfect. So let's take a look at these scripts. So first we have the level select UI. That's a very simple script. Let me show you what that looks like. Is that, there it is. Very easy. Basically just playing music for the audio manager. So we're loading in a reference to the audio manager. Again, I could have just created a public reference, but whatever. So we're loading in the music from the audio manager and playing the background music. And then we have a go back button, which allows me to go back to the main menu whenever I click it. So here's our go back button. We click that, we go back to the main menu. The other big scripts, well, the actual big script, that was a super simple script. The big script here is the level select manager. There she is. That is not the one. Is that the one? Yeah, that is the one. So it's not a big script, but it does a lot for me. What it does, so we have public references here. We have that button container to tell it where to populate the buttons. We have the level button prefab, and then we have the number of levels. So all it is just a very simple for loop. It's just saying for the number of levels, we're just going to instantiate a button. That's basically it. So it just builds that entire menu just right away, just using a very simple for loop. Super, super easy. Let's talk about the button itself. Is that the level select button? There we go. So this one is a little bit more complicated. Basically what this is doing is we have public references to the level, the text that's on the button. So 1, 2, 3, 4, 5, whatever level it is. We also have an array of stars, our 3 stars right there. And then we have a reference to the button itself. So here we have a private integer called level index, just to get, you know, the actual level from the build index. And then we have an offset, a build index offset. The reason why I have an offset in here is because if we look at our build menu, we'll see all the scenes. Let me open the scene list. We'll see all of our scenes. We start with the main menu and then level select, and that takes us to index 1. Level 1 doesn't start until index 2. So I needed to offset the actual index number so that we were getting to the correct level. So we need to go from 0 to 2. So I just created an offset. Super easy, super quick way to handle that problem. All right. So then we have this setup function. And this function is basically setting up our button. We set our level index to be the index of the actual level. We pass that in when we call setup. We're setting the text to be the index +1. And that's we're converting that to a string. We have our star count, which is going to pull that from the level save manager that we've built, which handles all of our level progress. We have a function in there called get stars for level. And then we have whether or not that level is locked or unlocked. A level is locked until you get at least 1 star on the previous level. Okay. And we're setting the button interactable value based on whether it's locked. So then we have another for loop, which basically loops through the amount of stars in that level's button. And we're basically setting it active based on the star count. So if we only have 2 stars in that level, we're only going to activate 2 stars on the button. We also have we have an on-click method, add listener, scene manager, load scene. So here's the deal. I could have, this is a situation where you can't create a public reference for this. And I can't use the on click method that's in the inspector. Let's find a button. Let me just show you. I'll just open up the prefab for this. This is something that you might struggle with if you're trying to do something like this later. So notice that this on click is empty, right? Because this is a prefab button, meaning I'm going to have to, the same button is going to be loaded every single time I want to have a button that can go to a specific level. If I put in here that I want to go to level 4, right? Then every time I load this button and I click it, I'm going to go to level 4. I can't do that if I hard code it in, or if I assign it in the inspector. So here I have to add a listener for this specific button, say scene manager.load scene level index plus build index offset. So I essentially have to account for what build index is this button attached to, and I'm going to load that scene whenever I create the button. That's all. I mean, I guess I could have, instead of doing an add listener, I could have just had this just made this a custom function and then add. Yeah, there are other ways to do it, but I like the way I did it. It's nice. And then I have a debug statement here just telling me which levels are loaded and what my star count is. I threw that in there because I wanted to troubleshoot this menu. It wasn't working the way I wanted it to at first. So I was trying to figure out. And what happened was it was that offset. I didn't realize. I don't know why I didn't realize. This is basic day one stuff when dealing with arrays. I forgot that the build list was an array. And so I was like, why is it not going to level 1? It's, level 1. I was like, oh, because it's the third index in the array. So it's going to pull up index 2. And anyway, so this helped me to troubleshoot what was happening there and fix that problem. Let's take a look at the level save manager since we've already talked about it a little bit. Level save manager. There we go. So this script, basically what it does is we have a couple of functions here. One is save stars for level. What this will do is it basically takes in the level index and the number of stars. We have a current and best. So it's tracking what the last current best score was for that game or for that level. And if you don't get better than your current best, then it doesn't do anything. If you do, then it updates the player preferences with your new best. So if I got 1 star last time and I got 3 stars this time, then it updates everything with 3 stars. If, there's no point in overriding it if we got less than or equal to the same amount of stars. This get stars for level basically just returns what's in the player preferences for how many stars we've received for that level. Our is level locked function just checks to see if we've earned at least 1 star. So first of all, it says if level index equals 1, return true, because 1's always going to be unlocked, or equals 0, then return true. Get stars for level index -1. Basically, we're looking at how many stars we actually received. Get highest level unlocked. This is how far in the game we've completed. So what's the last level that we've actually finished? That's what this function does. And then we have reset all progress here. This function just basically resets your player preferences. So it deletes all of your player preferences and then lets you save it after you've deleted everything. So I wrote this function in here because I wanted to make sure I can reset the level select screen whenever I needed to. And I have this tied to a key press on my keyboard in my game manager. Okay, let's get into an actual level then. Let's go to my scenes. Let's go to level 1 and we'll save. So level 1 has a little bit more going on than all the other levels because I have this tutorial. Let's talk about the tutorial first. So that is, where is my tutorial? It's in my HUD and I have my tutorial overlay. Okay. has a left hint and a right hint. Basically, it's super, super simple. This tutorial overlay script is doing all the heavy lifting here. Let me show you what that looks like. So basically what we're doing is we're checking to see if we're on mobile. If we're on mobile, then we change the text to be tap here to move right, tap here to move left. If we're not on mobile, if we're doing anything else, we're playing on PC or on the web, or in the Unity editor, we're changing it so that it says this instead, because these are the keys. We have an update function here that's basically checking for inputs. If we press A or left arrow, then the on left pressed is going to run, which basically turns off that tutorial message. It gets rid of it. Same thing for D, and for right arrow, it turns on, or it calls the on right pressed, which again gets rid of the tutorial. And then once left and right have been cleared, then we're just turning off that game object, just getting rid of it. It doesn't need to be loaded still. So we get rid of that. So that's the tutorial system. Very simple, very clean, very easy. No big dealio. All right, let's take a look at all the objects in the level. Okay, let's talk about our marble first. So our marble actually it has two scripts. Well, let me show you. Let's grab our marble. We have a couple scripts on the marble. We have, first of all, a trail, which is a particle system, which just follows it as it goes. The marble itself has a couple of scripts attached to it. It has the constant bounce controller, which we're going to talk about. That's basically our main player controller for the script, or for the game. We have a gem collector script, which started out as simply a gem collector, but I'm kind of using it to handle all of its collision interactions in the game. You'll see that when we get there. And then smooth rotator script. That's the rotator script that I already talked about. I showed you in the main menu. So let's talk about constant bounce controller. Okay, this is a very easy function. Basically, it's a basic player movement function, but it's different than others because this has a constant bounce, right? We're constantly moving vertically. So it was a bit different from what you'd expect. So we have a bunch of public references to things like how fast we're moving vertically, how fast we're moving horizontally. We have a max horizontal speed. So I can actually, I wrote this so that I can have it like kind of speed up and slow down. But the more I played with that, the more I tested it out, the more I realized I did not like it at all. It didn't feel good in this project. So I kind of left that. I just kind of set them to the same value so that we wouldn't have to have that weird floatiness. It didn't feel great. And then we also have an invulnerable time. This was the last bug that I fixed. Hopefully I fixed it. I haven't heard anyone tell me that it's still happening, but there was an issue after I made my enemies. I added a script to them that allowed them to move in different directions because the game wasn't as difficult as I wanted it to be. And it opened up some level design options for me. So I created a movement script for my enemies. When I did that, I was noticing that sometimes when I died, I would get hit twice and it would take 2 lives away. So I created a vulnerability or an invulnerability system in this script that basically, as soon as I lose a life, I become invulnerable for a certain amount of time. And then, yeah, that's basically all it does. It makes me unable to be hurt for a certain amount of time. I have a frozen variable here, which I can turn on and off whenever I pause the game or, teleport or whatever. Bounce cooldown. That way, I was having an issue with, when I played it on mobile, I was hitting the top and then it was doing this weird, stuttering thing. So I created a cooldown so that it wouldn't bounce a bunch within the same frame. And then my audio manager. So my start function here is just loading my audio manager. So we have our update function. Basically, if is frozen, we return, meaning we don't even run the update. We just don't do anything. It's a very easy way to handle being frozen. So we have if application is mobile platform. So all of this is the touch controls for the mobile. Basically, we're checking for a touch. We are getting that touch position. We're setting that based on the camera screen to world point. This is all standard touch screen controls. So we have, notice that I was in the beginning, this is one of the first scripts I wrote. I was good with comments, kind of showing me what I'm still doing. And then as I kept going, as I added stuff, I just stopped writing comments. So anyway, we have all of our movement here with our touch, blah, 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 clamping it. Yeah. Else, meaning if we're not touching anything, we still want to actually move on the vertical. So we're transforming our position by a vector 2 or vector 3 value. So 0 on the X, move direction dot Y times vertical speed. So that's our Y movement. And then 0 on the Z axis. And we're multiplying it by time dot delta time. So we get smooth movement every frame of the game. Cool. Then if we're not on mobile, then we are just taking in, we're basically just taking in movement from our axes, our movement axis, technically our horizontal movement axis, and we're applying that. We have our freeze. Basically, if I freeze the game, then is frozen turns true, which makes it so that nothing happens here. We basically return in the next frame. We just stop everything. Okay. So we also have collision. So on collision, stay 2D. Basically, this is helping me to determine if I hit the top or the bottom of a vertical surface. So let me show you here. It's a little bit easier to explain. So I didn't want the marble to reverse direction if it hit the side of a collider. I only want it to reverse direction if it hits the top, or if it hits the bottom or the top, right? So in this function, what we're doing is I'm checking to see if I'm hitting the top or the bottom. If I am, we're playing the bounce sound here. Remember, with that overloaded volume setting, which is very, very low, we're basically changing its move direction times equals -1, basically multiplying its movement direction by -1, which flips it from a positive to a negative or a negative to a positive. Cool. So that's our movement script. Let's take a look at our gem. Where is it? There it is. At our gem collector script. So in here, really, I just have an on trigger 2D check, and we're comparing tags. So if we hit a gem, then we play that particle explosion that happens when we hit a gem. We call this game manager gem collected function, and we destroy the gem. If it's a key, it's basically the same thing. Play a particle explosion, we destroy and call the game manager. We have a key collected function in the game manager. And then if we hit the win zone, then we call the level complete function. Let's talk about the game manager since we've already referenced it. This is the big guy. This is the big one. All right. So the game manager handles pretty much every interaction in the game. We have a lot of public references in this game manager. Basically, we have how many keys are in this level. Some levels have none. Some levels have 2. Some levels have 3. So at the beginning of the level, or for every level, I wanted to be able to set how many total keys. That way the HUD will only update with the amount of keys that are actually in the level. So you're not running around looking for a key that doesn't exist. You can just look at the HUD and go, okay, I have 2 out of the 3 keys. I don't need to keep looking for more. We have our keys collected value. Total gems in the level is the same idea. I was playing around with the idea of having a different number of gems in every level, but 4 just felt nice. And I never really found a reason to have more than 4. So I just kept it consistent, 4 gems per level. We have our life system, so the max number of lives, and we have lives remaining. We have a spawn point, so that's going to put our player back to where they begin the game or begin the level whenever they die. That's what our spawn point does. We have a respawn delay so that it doesn't spawn automatically. It gives us a second before it spawns so that we can kind of, you know, take a breath. So it's not a whole lot. I could probably change the delay setting there and make it a little bit nicer, but I kind of like the way it is right now. What I probably should do now that I'm thinking about it is probably have a teleport delay. We'll talk about it when we get there. So we have our awake function. This function here is basically checking to see if we have this game manager function in the level. If we do, then we just say don't destroy. Basically, we don't want this to be destroyed. We want this to be the same game manager from level to level. So this is what this function is doing. It's kind of making this a global object that we can use in every level. If I didn't do this, then I would have to make a public reference to the game manager in every scene and then assign it in the inspector. So this is kind of the way to do that for classes in Unity or for scripts. So I've shown you how to do it with functions. This is the way to do it with classes. Okay. So on scene loaded. So once the scene gets loaded, this is going to be called whenever our scene gets loaded first. Then we are, we're setting the level complete to false at the beginning. We're resetting the progress of our level. This isn't reset our save game. This is resetting the level progress, meaning putting all the keys back where they go, locking all the locks, all that stuff, putting the gems back where they go, that kind of stuff. We're going to set our spawn point and our HUD. We are going to play music. We're going to update total keys and total gems using find game objects with tag. We're going to look throughout the scene, look how many objects we have and set those there, which now that I'm thinking about it, I wrote this line so I didn't have to update it in the inspector every time I built a new level, and I've been doing that. Whatever. A week is just not enough time to make a video game cleanly. All right. So we have add key. Basically, we can call this function whenever we collide with a key, which increases our keys collected. Same thing with gem. Same thing with losing a life, except we're losing a life instead of adding keys. Reset progress, again, resets our keys collected to 0 or gems collected to 0 and puts our lives remaining back to max lives. Then we have our start function down here, which basically does all the same things we've already done. Do I have 2 start? There's no way. I have on scene loaded. Oh my gosh, I'm doing the same thing. Whatever. Fine, whatever. I'm doing the same thing in 2 different places. Whatever, it's working. It's not broken, so it's just inefficient. Okay, anyway, so then we have our update function, which is basically just checking for a couple of things I threw in there for debugging. R is going to reload the scene for me, and L resets all my progress and my player preferences if I want to do that. Then we have gem collected, so adding a gem and then playing a sound effect. Honestly, why do I have a gem collected and an add gem function? I could have just done all that in the whatever. Again, guys, this is not perfect code. Please, please don't think that this is supposed to be how you're supposed to do it. This is not efficient at all. All right. Then we have our level complete function, which basically will be run whenever we hit the win zone. We're updating level completed to true. We're playing the level complete sound effect. We're stopping the music. We're going to basically stop the player from running. We're basically freeze the player. We fade in to our level complete screen. We show the stars that we've collected in that level, or that we've gained in that level. We get the active scene so that we can update the next scene whenever we click the button, or go to the next scene when we click the button. Actually, I changed it so we go back to the main, or the menu select, level select screen. That's what I'm looking for. Oh, that's what this is for. This level index function, or this level index variable. It's basically just getting what actual index, what level we're on, so that we can properly assign the stars to that level. If HUD UI does not equal null, HUD UI set active to false. Okay. Okay. All right. So then we have load next level, which will load whatever the next scene is. Again, I changed this so that we're not actually using load next level. We're just loading the level select screen. We have our key collected function, which does all the things you're supposed to do. Now, this is actually a little different because what we're doing is we're finding all of the objects that are locked gates in the level, and we are checking to see if we should unlock that specific gate. So we have a for each loop that's checking all of the locked gates in our level, and it's checking to see if we should unlock it. If we should, then it unlocks it. If we shouldn't, then it just reduces it by 1. We have what happens when the player hits the hazard. We lose a life. We play that sound effect. If lives remaining is less than or equal to 0, then we restart the level. And we have a coroutine here for respawning the player. Restarting a level is pretty easy. We basically just load the same level that we're in, and we reset the progress of our game manager so we don't start with keys that we've already collected and whatnot. Respawn player is easy again. All we do is we basically just we stop our movement. We fade out the screen. We wait for a moment. We reset our position, and then we fade back in. That's basically it. So we're snapping, we're setting our character back to the spawn point. We're setting the camera back to the spawn point, and then we fade back in. And then last thing we do is we turn back on our movement so we can actually move again. Get star count. This is what's going to control whether or not you've earned a star. So we start with 1 star. If you beat the level, you automatically get a star. If lives remaining is equal to max lives, meaning we haven't lost a life, we get another star. If gems collected is greater than or equal to total gems, and total gems is greater than 0, then we also get a star. I could have even just said if gems collected equals total. Why did I do it this way? It's because I wanted, yeah, anyway. And then we have an on destroy function, which basically deletes the scene once we've, yeah, anyway. So that's the game manager function. That's a big boy. That's the biggest one in the game. All right. So we have our gems. Gems are easy. They don't even have scripts attached to them. They're just there. They do have an animator because this is 3 frames. Let me show you my artwork real quick. Go to my sprites. So this is 3 frames for the gem. So it rotates through these 3 frames. That's what the animator is doing. Oh, I still had that in there, didn't I? So I decided, I was like, you know what? The background behind the playable area needs to be a little bit more dynamic. So I spent some time creating this background, and then I added a 3D plane, and then I wrote a script to basically create a parallax thing, and I played the game, and it was gross. I couldn't see anything. My particle systems weren't showing up. It was hard to track my player and everything, so I kept it simple. Anyway, so that's that. The end game doesn't have any scripts attached to it either because I'm handling all of that in my game manager. It does have the Wind Zone does have the smooth rotator script attached to it though. Let's see. What else have we not talked about? Oh, the camera follow. Let's talk about camera following. So this camera follow script is actually pretty simple. It's the standard camera follow script. Basically, we're just getting a reference to the player, and we're setting that to be the target. We have a speed at which we can follow the target, basically, or a smooth speed. Sorry, this is a speed at which we're going to smooth our camera movement. In this one, sometimes you'll have vertical and horizontal settings, but I just wanted this to follow the player perfectly on the x-axis, and I only wanted it to follow the player. I wanted it to have a little bit of give on the y-axis, because I felt if it was automatically following the player on the x and the y, it would be way too much camera movement, and it would get really, like, you'd get sick playing the game because we're constantly moving up and down. So that's why I created the script. I could have just made this a child of the player, which works fine for some games. For this, it wouldn't have worked at all. It would have been way gross. So anyway, so we have a couple functions here. We have our late update function. And the reason why it's late update instead of update is because this will happen after everything else in that frame call has happened. So we want this to be the very last thing that happens. Because we don't want this to get in the way of our collisions and things that are more important. Then we have snap to target, which basically just snaps our camera directly to the target. We have our game manager, gem collector, hazard. Hazard is very simple. It basically just checking that trigger. And I also have my is vulnerable system in here as well. So as long as it's not vulnerable, then we do this. If it is, then we ignore it. HUD icon, did we look at that? Anyway, that's a simple script anyway, so. Sure. I didn't know I made any changes. HUD manager, level complete, level save. I think we've looked at everything at this point. The locked gate, actually, we haven't looked at. Let me take a look at that. Oh, and I also have a particle manager. I'll show you that as well. So the locked gate, this was a very specific system that I wanted to get right because it's kind of the meat of all of the puzzle solving in this game, is collecting the right amount of keys to get through this a certain gate. So every gate has a specific number of keys needed to unlock that gate. And then I added a shake to the gate when it gets unlocked because I thought that visually it looks a whole lot nicer than it just fading out. We also have a sprite for when it's unlocked. That's the red dashed outline around the gate whenever it's completely unlocked. Let me pull up a level that has some gates in it. So when this gets unlocked, it's actually a red dashed outline. It's this. So you can, it'll show you that there used to be a gate there, but it's not there anymore. I wanted that visual feedback. I think it's important. So we're going to check. Oh, so on start, we basically are getting references to everything we need. And then we update the key label, which is down here. Basically, we're basically setting the number that's on the gate to the number of keys needed to unlock that gate, and that updates as well. So if we get a key, then the number of keys needed. So we do keys needed minus the keys collected. So at first, if you need 3 keys to get through this gate and we haven't collected anything, then it still says 3. If we collect 1, it says 2, and then 1, so on and so forth. So then we have an unlock function, which starts a coroutine called unlock sequence. Again, this is a coroutine because it needs to happen at the same time as other interactions in the game. So what we're doing is we're doing a shake. We're shaky. And then we are fading that out. And then we change the sprite to the unlock sprite. We're disabling the collider. And we're destroying the key label because we don't need the number anymore. We'll just get rid of it. So that's that script. Let's see. I think the only thing I haven't shown you... Oh, here's the moving hazard script that I wrote. This is the last thing that I did. Basically, I have 3 different types of movement. I have, well, 4 technically, because I have none, horizontal, vertical, and circular. And I have basically an enum that's handling those different types. And I'm checking to see which type it is using a switch. And if it's horizontal, then I'm moving on the x-axis. If it's vertical, I move it on the y-axis. And if it's circular, we basically move in a circle. That's it. Particle manager just basically runs specific particles. Same idea. We have an enum with, or actually not an enum. I just have public references to those specific particles. And then if something happens, we spawn basically that particle type. Oh, I do have an enum down here. Yep. Handling which kind it is. Perfect. Pause menu, screen fader. This is a very simple fading script. It just fades out. I don't know what I was doing there. Was I trying to do... What was this? Oh, I wrote this very complicated way to do it. And then I was like, wait a second. I just want to go to level select screen. That's what it was. This was what the code was before. When I clicked that button, it would take me to the next level. But then I just changed it all with level select. But I kept it there just in case I wanted to go back to it. But I didn't. Screen shake, very easy. Just shake my screen. Actually, it was kind of a bit more complicated to build than expected. I have my main camera is inside of an object called camera shake holder, which that object has the camera follow script attached to it. The main camera itself has the shake script attached to it. So whenever I shake it, I'm shaking the camera, not the thing that it's inside of. So anyway, and then teleporter. This is the last thing. So the teleporter script is actually pretty cool. What it does is it has a target destination. So I'll have 2 teleporters in a scene. One teleporter, its target is the other, and the other teleporter, its target is the original, right? So basically I'm linking them together. And then we, finding our audio manager, basically whenever we enter that trigger, then we are starting a teleportation coroutine. Here's the coroutine here. Basically, we have a cooldown here, checking to see if it's cooling down. We play a sound effect. We freeze our character movement. And then we basically look for the sprite renderer on the player. We will fade out the player, transport them to the other teleporter, fade it in. That's it. And then we unfreeze the player. That's the entire thing. And we have a cooldown time here, which Honestly, I can probably increase the cooldown time to make it a little bit better for the teleporter, which I actually did. I made it a public reference and I changed that in the prefab. Let me show you. So in here, I'm overwriting that 0.5 to 1.5. I could probably increase it just so there's more time between getting out of the teleporter and being able to go back into the same one. But anyway, I think that's it. I think that's the entire project. Like I said, it's a lot of scripts, a lot of stuff to build, and what you're seeing is the final version. Like as messy as the code is, it's the final version. So this is not as nice as it was when I was building it. It was a lot of how do I make this work? What do I do? A lot of troubleshooting, a lot of, especially since it's been a long time since I've developed anything in Unity. So this was kind of a bear to put together. If I had to build this game again, I could probably build it in a couple of hours because I spent the whole week figuring out all the kinks. If I was to write a tutorial showing you how to build this from soup to nuts, I probably could do it in about 2 or 3 hours, even while explaining everything I'm doing. But that doesn't take into account the artwork. Making the artwork took me a couple of hours, and all that stuff. But troubleshooting takes longer than you expect. Oh, and level design, coming up with interesting ideas for levels, that was pretty tough as well. Especially because I did it at a time where I was mentally and physically just exhausted. So it was hard to come up with ideas. Anyway, but that's it. That's the project. That's the whole thing. There's some stuff I didn't go into, but it's fine. I showed you the basic stuff, the big stuff that you really needed to see. But yeah, that's what this looks like. Now, again, it's only about 5 minutes worth of gameplay because I only have a dozen levels. To make this into something that's actually commercially viable, I'd need to create another probably 45, 50 levels just to get it to a place where it's actually worth someone downloading it and playing it. But that takes time, and I'm not going to take that time. I'm going to leave this where it is for now. I'm going to let you guys play it, test it, find the bugs, tell me what you like, what you don't like, what pisses you off, what you want to see more of, that kind of thing. And maybe in a little while, I'll come back to it and beef it up and make it better based on your feedback. But anywho, that's the code. That's the code review. I thought this was going to take twice as long as it did. So I'm going to cut this video here for the, I don't know, 2 of you that actually watched this far. Thank you. This is really fun to do stuff like this, and I'm really happy that you followed along. Yeah, anyway, I'm going to go play some video games now. I'm not going to make one. I'm going to play some. I'm going to go play some Assassin's Creed or something. All right. I will see you on the next project. Thanks. Bye.